which enable us to see the things surrounding us. That is nothing but light energy. So, what is this light energy? What it is giving? This light energy gives sensation to our eyesight. So, to see the things surrounding us, we need two things, two factors. One is light, presence of light. Second is vision in the eye. Now, if these two are there, we can able to see the things. But, still the question how? How is it possible? That we will be learning. So, already in the lower classes, we have studied about light, that light undergoes one property. That property is known as rectilinear propagation. That means light always travels in straight line. Rectilinear propagation, that is light always travels in straight line. Now another nature also this light will have. This energy is having dual nature. What are this? One is wave nature. Second one is particle nature. So about the particle we will be learning afterwards. Now this energy will be traveling in straight line. So the property of light is, again, this is one property. Basing on this property, light undergoes 5 phenomena. These are the phenomena. What light undergoes? What are the phenomena? 5 phenomena that we are dealing in this chapter. That is reflection, refraction, then dispersion, scattering, then another one is diffraction. Now, coming to how it is undergoing this phenomena, which basing on the phenomena of light, all the materials are classified into 3. One is opaque, then transparent, and third is translucent. First one is opaque, second transparent, third is translucent. Now basing on the phenomena of light, all the materials we have classified into opaque, transparent and translucent. Basing on that source, all the materials can be again classified into 2. One is luminous and another one is non-luminous. The materials which gives out light are known as luminous source or luminous bodies. Non-luminous, which does not give out light or which does not produce light, are non-luminous. Mostly the non-luminous bodies are the opaque bodies. Now coming to the phenomenon, luminous, example sun, stars, fireflies, these are all self-luminous, even candle, bulb, artificial luminous bodies. Non-luminous, which are wood, stone, tree, human body, these are all non-luminous bodies. Now coming to opaque, transparent, translucent. In lower classes we have studied that opaque bodies are those bodies which does not allow to pass through them. Now a little bit change of this phenomena we will be a reflection definition, opaque bodies definition basing on the phenomena we are discussing, no? So whichever object will bounce back the light, those objects are called as opaque. Most of the light which is hitting the object, if it is bouncing back, coming back into the same medium, the phenomena is known as a reflection. So most of the materials which undergoes the phenomenon of reflection are known as opaque. The materials are undergoing, there will be absorption of energy. So whenever these phenomena is occurring in the objects, materials, the materials will become little bit hot. This proves that absorption of energy will be there. So opaque objects are those objects which undergo the phenomena of reflection. Now transparent are those objects which undergo the phenomenon of refraction. Lower classes, what you have studied, that the object which allows the light to pass through it is known as transparent. But the objects which undergoes the phenomenon of refraction are known as transparent. Next is translucent. Translucent materials are those materials which undergoes partial reflection and partial refraction. If partial reflection and partial refraction takes place, such objects are known as translucent. Example, ground glass, oil, paper, tissue paper, butter paper, these are all examples. Whereas transparent glass, case of a bulb, eye spectacles, these are all examples of transparent. Now coming to opaque, wood, stone, these are all. Now coming to, see, this is the basing on the phenomena of light. We have divided all the materials into 3 groups, classified, and basing on the source, that is production of light, we have divided into 2. One is luminous and other one is non-luminous. So this is all the basics you have studied, and some more basics also you have studied. What are the other basics what we have studied? Reflection is nothing but bouncing back of light rays when it hits the objects. We are able to see the things. Now sun rays are coming from far distance and falling on the earth. Now when it is received, the earth is reflecting them back because earth is opaque. Opaque body is reflecting it. This is the natural reflection. When it is touching the surface of the earth, it gets reflected back, and whatever object is reflecting that object we can able to see. Then see, because it is receiving, reflecting, a reflection phenomenon is occurring, and earth surface will be hot. So absorption also will be there. Wherever energy is there, undergoing phenomena, or when it is producing also, absorption will be there, dissipation will be there. Dissipation, giving out will be there. Now whenever light is passing, if you consider sun, so many rays are coming from the sun like this. Now when you are seeing these light rays, they are coming back from here, from a converging point. Sun is like converging point from here. So many rays we are drawing like this. Now when you see, suppose if you are putting anything here, see a curve. Now from here you make it here, this, still go like this, all. This is called as one wave front. This is what a wave front. When it is going from this point far, by reaching the far off point, these rays will become parallel. What they will become? Parallel. Now in this parallel, what is meant by a ray? The path in which the light ray, the light energy is traveling. The path which describes a single path, the path which describes the traveling of the light is called as a ray. This is the path of light in which it is traveling. Suppose a group of rays you are considering is called as a beam. What you will call? Beam. Single line which describes the path, traveling path of light energy is called as ray. Many rays clubbing together coming from the source is called as beam. If this group of rays are parallel to each other, it is known as parallel beam. Suppose if these rays are coming and converging and meeting at a point like this is called as meeting at a point, this is called as converging beam. Converging beam. Now suppose if the rays are going away from a point like this, like how sun rays coming to the earth. This is suppose sun if you. This is called as diverging beam. So a single line is a ray which describes the path of the light energy. Sub group of describing source, it is called as a beam. If this beam is parallel, all the rays are with each other, this is called as parallel beam. If this beam of light is coming and meeting at a point, focusing at a point, it is called as converging beam. Or from the source it is moving away in all different directions, this is called as diverging beam. So ray, beam, converging beam, diverging beam, parallel beam. These all will describe the path of the ray traveling or the path of the light energy traveling. Basing on the rectilinear propagation. Rectilinear propagation is nothing but light traveling in straight line. Basing on that, what we have considered, there are 5 phenomena. One is reflection. The second one is refraction. Next, dispersion. Next is scattering. In detail we will be learning this. Now, in between one term I told, that is diffraction. Now what is mean by diffraction? We will be seeing. Now what is reflection? Simple words, bouncing back of light rays into the same medium. Light ray bouncing back into the same medium. When it is possible? When it hits an opaque object, it will bounce back. This phenomenon is known as reflection. Suppose, see, the light rays are falling on me and myself, I am obstructing the light. So whatever the edges of mine will be there, that edge points, the light will drift. Drift means skids down, slips down, and it all will converge at a point on the wall, and there you will observe something. What is that? My shadow on the board. This is slipping down and converging at the back of opaque object is known as diffraction. What do you know? What do you call it as? Now suppose I am keeping my hand here. See, the light is coming parallel, hitting my hand. Since my hand is opaque, it reflects back. Most of the light which is hitting my hand is reflecting back, but at the edges, the points at the edges where the light rays hitting, they slips down and converge at the back at a place. There they will converge and form the shadow. Now my hand shadow you can able to see. So these are all slipping down and bending and going and converging at a point. This bending of light rays at the point of opaque objects and slipping down, bending and traveling again in the straight line and converging at a point at the back of the object is known as diffraction. Now reflection is hitting and coming back into the same medium is reflection. So two phenomena you are observing here in the opaque objects. Whenever light ray is falling on opaque object, whatever the surface it is touching, it is bouncing back into the same medium, whereas at the edges of the opaque body, at the points where it is slipping down and bending and traveling again in the straight line at the back of the object and converging at a point, that phenomenon is slipping down or bending down at the points of opaque object. This phenomenon of light is known as diffraction. So diffraction will form the shadow. Understood? Now coming to how many kinds of reflection is there? What is mean by reflector? Now whatever the object, suppose if you have seen, see my hand, just think that this is plane mirror. This white part is the reflecting surface, this is the coated part. So this is plane mirror. So plane mirror. So single hand when I am keeping that, this is plane mirror. Think that this is the plane mirror. Whenever light is hitting the reflecting surface, the surface which is reflecting, undergoing the phenomenon of reflection is known as reflector. What is reflector? Surface of the opaque object where the reflection is taking place, that is a reflector. So there are two kinds of reflectors, smooth reflectors and rough reflectors. Smooth reflectors undergoes smooth or regular reflection, whereas rough reflectors undergo diffused reflection or irregular reflection. Since the surface is irregular in case of rough surface, this is rough surface, this is smooth surface. So whatever light is coming and falling in this will be reflecting back in smooth. So all the rays which are forming on this smooth surface, this is the coating part thing that. Now they will bounce back like this. Now all the rays which are falling on the smooth surface and moving back the reflector rays also, both are parallel. See, this is incident ray, this is incident ray. Incident rays are all parallel. Same way reflected rays are also parallel with each other. Now if you draw a perpendicular to the surface of the reflector, from the reflector if you draw a perpendicular, this divides the incident ray and reflected ray into two parts. So the incident ray with the perpendicular, this perpendicular is known as normal. With the normal, whatever the angle made by this is called as angle of incidence and it is represented by I. Whereas the reflected ray, whatever it is making angle with the perpendicular or normal, the surface or reflector, it is known as angle R. Angle I is equals to angle R. This is the first law of reflection. This is the first law of reflection. Now coming to the second law, the point, the incident ray, reflected ray and the perpendicular drawn to the reflector all lie at the same point of incidence on the same plane. So they are all lying in the same plane. Reflected ray, incident ray, normal to the reflector all lie at the point of incidence on the same plane. Now this is the second law of reflection. Now, reflected ray and incident ray, reflected ray and incident ray lie on either side of the normal. Angle made by incident ray with the normal is known as angle of incidence. Angle made by reflected ray with the normal is known as angle of reflection. And angle of incidence is represented by small I. Angle of reflection is represented by small r. Angle I is equals to angle r. This is the first law. Then at the point of incidence, all these three rays are lying on the same plane is the second law. And angles made and on either side of the normal, this is the third law. Laws of reflection will not be changed even though it is a regular reflection or irregular reflection. Only the surface differs. And this is one difference. Second difference is whenever the light rays are falling on this and reflecting back, the reflected rays and incident rays are not parallel, non-parallel. Same way reflected rays are non-parallel with each other. This is the second difference. About the reflector surface difference, and only here see all the incident rays are parallel with each other, all the reflected rays are parallel with each other. Whereas in case of rough reflection or diffused reflection, incident rays are non-parallel with each other and reflected rays are also non-parallel with each other. This is one difference. And reflected surface, this is smooth, this is rough. This is the second difference. And these are laws of reflection will not be changed in either surface of the reflector. Now, how the reflection takes place in the plane mirror and what are the image characters? What are the two kinds of images will be formed? Definition of reflection. Reflection is nothing but bouncing back of light rays whenever they are hitting an opaque object and traveling into the same medium. Bouncing back, that is whenever light rays are hitting a reflector, they will be coming back into the same medium. Suppose this is the reflector. Think that this is a plane mirror, and draw a perpendicular. This is called as normal. And suppose the light ray is from the source coming and hitting it. This is the incident ray. The ray which is hitting is called as incident ray. Now from here, this point, it bounces back with the same angle into the same medium. This is called as bouncing back ray is reflected ray. This is angle of incidence. This is angle of reflection. Now this is how the reflection takes place in a plane mirror. Now what type of image is formed? We are saying it is virtual erect. Now there are two types of images formed. Real images. What is the main difference between virtual image and real image? Virtual image cannot be caught on the screen. Whereas real image can be caught on the screen. Opposite to this, can be caught on the screen. Now virtual image will always be erect, straight, whereas real image always be inverted. Now how this is possible? Why it is like that? Now we will see in the plane mirror always virtual image will be formed. That is, it cannot be caught on the screen and always it will be erect. Now what are the characteristic features? It is equidistant from the mirror. The image will be equidistant from the mirror, beyond the mirror. It is always virtual erect. Equidistance, same size, laterally inverted. That means right side will be seen as left side will be seen as right side. So it cannot be caught on the screen. Now coming to the magnification, how you can see, suppose this is the size, this is the source object. Now how you will be drawing the line? From here you need to extend. Now one more point you take, this also extend. This is called as ray diagram. Where these two are intersecting, that you draw a line, measure it at this size and this size will be equal. This size equidistant, this distance and this distance will be equal. Equidistant are called as extended lines. Then this is erect, same size, and laterally inverted, that is right side will be seen as left, left side will be seen as right. Now coming to the types of mirrors. 3 types. One is plane mirror, then 2 types of spherical mirrors. Concave mirror, convex mirror. Now with the hand I will show. This is think that. Remember, this is plane mirror, your hand. This is the reflector. Polished surface. This is coated. Okay. Now your fingers you bend inwards. This is a curve, like a parabola. Like this. If I keep like this. This is, see, when reflector is inside inwards, that is called as concave. Because why I am showing hand, you please remember, whenever you are drawing the ray diagrams you won't do any mistake. Whenever reflector is inwards, then it is concave, that is reflecting surface is inwards. Now straight, again plane mirror. Now bend the fingers backwards. When you are bending, the inverse is the coated surface and this is bulge. That means when you want to draw this, how the curve is coming? Like this. Yes or no? Like this. Whenever this is, that is here the coated surface, this is concave. When coated surface is here, bending inwards and reflector is bulged out, this is called as convex. Then what about the plane mirror? When you are keeping straight, just like a line, this is coated surface, this is reflector, this is plane mirror. Now in this case always virtual erect image only will be formed. That means you cannot catch on the screen. Here same size, here always, this is also virtual erect. Always the size of the image will be smaller than the object. Small, diminished. Magnification will say. Magnification here refers to size. So smaller. Always it forms a smaller size than the object. The convex mirror forms the image, that is virtual image only. Now plane mirror also forms virtual erect image, but it is same size. This is called as converging mirror. This is called as diverging mirror. Showing with the spoon. See the spoon surface. This is the reflector inverse. This is concave. This side if you observe convex. Now when you are seeing with the spoon like this, my image will be inverted. When you are seeing like this, my image will be erect only. So Now you observe the candle flame, it is upside down in the spoon. Just the flame, upside down. Observe carefully, the candle flame is upside down. Now if I reverse this, straight. On the spoon you observe, it is straight. Yes, it is straight. Observe on the spoon, it is straight. Now when I am reversing it, it is in reverse condition. See, it is in reverse. Yes? Have you observed, children? See the flames, it's ulta. Yes? It is ulta, whereas this side it is straight. So this is convex surface, this is concave. This is real image, inverted, can catch on the screen, whereas this cannot be caught on the screen. This is virtual erect. See, in this case, candle flame is in reverse condition. Candle flame is reversed. In this case, candle flame is straight. See the video, two are not there, single, straight. Here see, here I am straight, convex. Now when I reverse, see my face ulta. See, this is see, now it's clear. My face is ulta. Now I am turning. See, straight. Ulta face. Straight. Convex. Concave. Concave. Convex. Again I am showing concave. Convex. Children, you observe these lemon pieces carefully. Now, if you consider full lemon, it will be a spherical shape. Now, a part of it, half of it, when you cut, you will get like this. Now, Now, when you remove the juice from this, you will be, this is the one. So, this is like a cave and this is the coated one. So, this is one kind of spherical mirror, which is that concave. Now, this part you think that this is the reflecting part. Now, this is the coated part. So, reflecting part is inwards. So, this is like a concave mirror. A spherical mirror which represents concave mirror. Now, on the mirror only, every time you can't draw like this. So, we will be representing only a parabolic shape. Now, on this, when you observe on the surface only, see here, one point will be there. This you will be considering as pole of the mirror. This is the pole of the mirror when you draw a straight line, because you are taking only the curve, no? So, if you draw a line, this will become the pole of the mirror. Now, when you reverse this, what will happen to the reflecting surface? It comes like this. So, reflecting surface is elevated outside and coating surface inside. So, if it is reflected surface is bulging like this is convex mirror. Now, where the pole of the mirror went? To the back, that is beyond. So, this is called as pole of the mirror. Now, we will be taking only the curves and we will be drawing the ray diagrams. This is like 3D picture. Now, when you are considering, this is the pole of the mirror. Now, this is the center of the lemon where all this point, you can say it as center of curvature. Now, from this till here, pole of the mirror, when you draw a line, straight line, that distance will give you the radius of curvature, capital R, and this is represented as C. Now, when you observe some lines, all are coming and meeting at this point, you see. This line, this line, this line, this line. So, when you consider the surface where it is touching and see, suppose rays are coming like this straight to it and touching this point and reflecting and meeting at a point. So, this is converging point also, you can say. Actually, this will be become for the lemon, it is center of curvature. But actually, if you consider a parabolic shape only, not considering this total lemon, then all the rays which are touching the surface parallel coming to this surface parabolic and reflecting back and meeting at one point, that is called as focus or converging point. So, the converging point, center of curvature and pole of the mirror, pole of the mirror is on the surface, center of curvature and converging point are in front of the mirror in case of concave mirror. In case of convex mirror, a pole of the mirror will be on the surface. This is the pole of the mirror. Now, if you see, they will be beyond. Center of curvature will be this side, it will be. Center of curvature will be at the back, that is beyond. Then, same time, whenever the reflecting on this surface, reflecting going back, if you extend, they will meet at the point. So, from that point you will be seen that all the rays will be diverging. So, this is called as a diverging mirror also, convex mirror or diverging mirror. Observe this spoon. Spoon, you see, this is inner surface. This is concave. It is reflecting. See, you can see my image in the mirror. See how it is. My image is inverted. How my image? It is inverted. Now, this is concave. Okay. Now, I will reverse this. This is convex surface. Now, when you are up, how is it? It is straight. How is it? It is straight. This is convex mirror. Convex mirror always forms a rect virtual image you can't catch on the screen.